So part 2 of our Chapter 7 review focuses on 7.4 through 7.7. We look a lot more at identities in this part of our chapter review, so you want to make sure you have those handy. If I was you, I would actually go through the Chapter 7 notes and just rewrite all of my identities so they're all in one place, so I don't necessarily have to flip back and forth as I go about solving these. Now, there are going to be some you probably don't have to write down, your reciprocal identities, maybe your Pythagorean identities, but the things like the double and the half angle identities, I self-select those up. I would just recommend writing them all in one place so you don't have to flip through notes to get to them. So the first thing says complete the following equation. Really, it's just like a fancy way of looking at an identity. We don't know what the right side's supposed to be equal to, but we're going to go about solving it as if we were doing a Pythagorean identity, or excuse me, a trig identity. So we've got tangent squared theta minus secant squared theta. Hopefully you're getting familiar with the fact that, hey, let's go ahead and write this in terms of sines and cosines. So tangent squared is sine squared over cosine squared, minus secant is 1 over cosine squared theta. And go ahead, once you've got it rewritten in sines and cosines, just keep simplifying. Do whatever is necessary to simplify further. So notice I've got two fractions that I'm subtracting, and they already have a common denominator. So my denominator is going to say cosine squared theta, and subtract across the top. Sine squared theta minus 1. Hopefully that's ringing some bells for you, but remember our Pythagorean identity says 1 minus sine squared theta is equal to cosine squared. Well, here I have sine squared minus 1, so that's going to actually give me negative cosine squared theta over my denominator of cosine squared theta. Well, anything over itself is just 1. Since I have a negative, my final answer is negative 1. So tangent squared theta minus secant squared theta actually reduces to just negative 1. All right, the next one, find the exact value of cosine of theta if sine theta is 5/13 and theta is in quadrant 2. So there's no guessing or no spending extra time figuring out which quadrant I'm in here. Excuse me. I know that I'm in quadrant 2. I'm going to sketch myself a picture. Since sine theta is 5/13, since sine is y over r, I know my y is 5 and my r is 13. So I need to find x. But I know since I'm in quadrant 2 that x is going to be negative. That's often missed. That's a common mistake, is we forget to make that negative, because when we do Pythagorean theorem, we're going to get a positive answer out. Just make sure that you are making that negative for the, since we're in quadrant 2. So x is equal to the square root of 13 squared minus 5 squared. Again, skipping a couple of steps there. Hopefully you're comfortable with that. 13 squared minus 5 squared is 144. The square root of 144 is 12. So x is equal to negative 12. So if I'm looking for cosine, I'm looking for x over r, negative 12 over 13. So not a whole lot new there. Probably a little bit of a review problem, but just really good to review that because it does come up in a lot of our other problems where we have to extend past that. So I want you to be comfortable with setting those pictures up. All right, some are different. Use the sum or difference formula to find the exact value of the trig function sine of 11 pi over 12. So exact value means we don't want to put it in our calculator to get a rounded answer, but I run into the issue of 11 pi over 12 not being in a position on my unit circle. So how can I find the exact value? Well, that's what we're going to use the sum or the difference formula. Now remember when we did these in class, I told you a lot of times there are multiple right ways to get the same answer. So you might pick 2 different values than I do. That's okay, do it. Finish it to the end and then see if you get the same thing that I got. You should. So 11 pi over 12. So the trick here, and this might be a little bit of guess and check, is we want to find 2 values that add up to 11 pi over 12, but that are on our unit circle. So I can rewrite sine of 11 pi over 12 as sine of 2 pi over 12 plus 9 pi over 12. And again, you could pick some different values there. Now, let's reduce those to make sure that they are on our unit circle. 2 pi over 12 reduces to pi over 6. That's good. That's a position on my unit circle. 9 pi over 12 reduces to 3 pi over 4. That's also good. That's a position on my unit circle. So I've satisfied both things I need to do here in order to use my sum formula. I've rewritten 11 pi over 12 in terms of 2 different angles that add up to 11 pi over 12. And when I reduce those values, I do find out that they're both on my unit circle. So now I need to use my sum formula. And my sum formula says if I'm adding 2 angles and I'm using the sine function, I can rewrite that as sine of the first angle, so sine of pi over 6, times cosine of the second angle, 3 pi over 4, plus cosine of the first angle, cosine of pi over 6, times sine of 3 pi over 4, that second angle. Now, I know what all those values are equal to, so I just need to go ahead and do a substitution. Sine at pi over 6 is 1/2. Cosine at 3 pi over 4 is negative root 2 over 2. Plus, cosine at pi over 6 is square root of 3 over 2. And sine at 3 pi over 2, 3 pi over 4 is positive root 2 over 2. Now, I've got rid of all my trig functions. All I have is fractions. The first thing I need to do is multiply each term together, and then I'll be able to add. So, when multiplying, I look at my first two terms, multiply across the top, 1 times negative root 2 is negative root 2. Multiply across the bottom, 2 times 2 is 4. Plus, second term, multiply across the top, square root of 3 times square root of 2. I can actually square root and, I can actually multiply what's under that radical and get the square root of 6. Over 2 times 2 is 4. Now I need to add. I've got my common denominator of 4. Since I don't have the same value under the radical, I can't add. You can multiply if your values aren't the same, but you can't add or subtract. So I'm just left with negative square root of 2 plus square root of 6. Now, your homework will sometimes write it differently. They like to pull the fraction out front, and they like to write when you have a negative, they like to put it second. So square root of 6 minus square root of 2. You will get this right if you plug in this as your answer. And honestly, I don't see anything wrong with that. We don't like to see the negative up front. If we can switch the order, maybe do that. But you don't have to write it with the 1/4 out front instead of over 4. I don't really see a big difference in that either way. But just wanted you to be aware that your homework will do it both ways. Next, if sine of theta is equal to 6/7, theta is restricted between 0 and pi over 2. That's telling me I'm in quadrant 1. Find the exact value of each of the following. So we've got some double angle formulas going on here and some half angle formulas. My biggest tip here, A, certainly don't try to do this in your head. I don't know if you could. And B, give yourself plenty of room to write. Sometimes when I do these, I try to squeeze them in a small spot, and I end up with like some square roots inside square roots. So those get nasty, and I don't want to have to get this wrong because I just wasn't clear with my work. So give yourself plenty of space to work these out. All right, so first thing I'm going to do before I even look at parts A through D is I need to figure out what my cosine value is. So I need to sketch a picture just like we've been doing. I'm told I'm restricted in quadrant 1. So I know both x and y are going to be positive. Sine is 6/7, which means that my y is 6, my r is 7. I need to solve for x. So x is going to be equal to the square root of 7 squared minus 6 squared. 7 squared minus 6 squared is 13, and that's not a perfect square. I can't reduce that at all, so I just get positive root 13 for my x value. So I'm going to just rewrite what I know sine theta is equal to 6/7 and add here cosine theta is equal to the square root of 13 over 7, x over r. All of that's going to help me solve parts A through D. So for A, I want to know sine of 2 theta. Now, remember, sine of 2 theta is just not 2 times sine of theta. We can't rewrite it that way. We have to use our double angle identity. And that tells us that sine of 2 theta is equal to 2 times sine theta cosine theta. That's one I would recommend having written down. Now, I don't know what theta is. I don't know my angle, but I actually do know the sine theta and the cosine theta value. So I can do a substitution there. 2 times sine theta is 6/7. Cosine theta is root 13 over 7. And now I've just got two fractions multiplied by 2, multiply across the top and across the bottom. 2 times 6 is 12, times the square root of 13 is just 12 root 13, over 7 times 7 is 49. Be careful. In this case, I'm done there. I can't reduce anymore. There are instances where the 12 and the 49 can be reduced. Make sure that you take that next step and give your answer in a simplified form. So that's for part A. Now let's look at part B. Cosine of 2 theta. Well, even though sine of 2 theta was just 2 sine theta cosine theta, that's not how we do our cosine double angle identity. There's actually 3 things you can do for it. I'm going to use the fact that cosine of 2 theta is equal to cosine squared theta minus sine squared theta. And again, you could do it however you wanted. And go ahead and substitute. Cosine squared would be a square root of 13 over 7 squared minus sine squared is 6/7 squared. And reduce, when you're squaring a number that's squared, you just get that value out. So I get 13 over 7 squared is 49, minus 36 over 49, and subtract. I've got my common denominator, 49. 13 minus 36 gives me negative 23. Again, if you can simplify that, if that reduces, make sure you take that step. So those are pretty straightforward. Now, parts C and D get a little bit uglier. This is where I'm telling you, give yourself plenty of space to write. So I want to find sine of half of my angle, or my angle over 2. That's called a half angle identity. And our identity tells us sine of theta over 2 is equal to 1 minus cosine theta all over 2, square root of that. Now, my actual identity says I need to take plus or minus. I need to look at the positive and the negative. In the case of this particular problem, since I'm told I'm working in quadrant 1, I know all my values are going to be positive. So I'm only looking at the positive value. But pay attention. If you do run into a problem where you're working in any other quadrant besides quadrant 1, you may need to work with the positive or the negative. Just make sure that you're paying attention to the quadrant you're in. So again, I'm going to go ahead and just do some substitution here. Square root of 1 minus cosine theta is root 13 over 7 all over 2. And this is where I said give yourself some room. Simplifying can get a little bit ugly. Let's look at just my numerator here, 1 minus root 13 over 7. If I want to do the subtraction, I need my 1 to be a fraction with the same denominator as my second term. So I'm going to think of 1 as 7 over 7. Then I can subtract. And here's my fraction. I know I'm going to have a denominator of 7. 7 minus root 13 is just 7 minus root 13. Nothing I can do there. All over 2, I haven't dealt with that bottom. Square root of all of that. So just take it piece by piece. If you need to break it down more, go ahead and do that. Now, fraction with a fraction, that's like I need to do copy dot flip or multiply by the reciprocal. So think of this 2 as 2 over 1. And I'm going to take 7 minus root 13 over 7 times 1 over 2, which gives me a new denominator of 7 times 2 or 14. So I've got 7 minus root 13 on top, all over 14, and I'm taking the square root of all of that. In this case, I'm done there. That's as simplified as I can get. Just be warned, there will be some instances where your denominator, where I have the 14 here, can be reduced with the radical. So let's say that was an 8. I would actually take out the 2, leave it square root of 3, and then that would come to the outside of my radical. So just know that you may need to reduce that denominator once more. If you need help with that, just let me know. And our last one's going to look very similar, part D. And I want the half cosine identity, which tells me very, very similar, 1 plus cosine theta all over 2. So, since I've already done something similar, I already did 1 minus, this is going to look very similar, 1 plus the square root of 13 over 7 all over 2. Now, once I did my subtraction with 7 root 13, it didn't change, so I'm going to go ahead and skip to my last step here and just use that same formula from the last one, but write it with an addition instead of a subtraction. So 7 plus root 13 all over 14. Square root of all of that. Take your time on these. If you have any questions, let me know. And one last one. This is from section 7, where we're working with the product of angles. And it says express the given product as a sum containing sines and cosines. Again, these are pretty long formulas with kind of a lot of differences and pluses and minuses. So don't get overwhelmed with trying to memorize it by any means. Just have it written down, preferably in one spot. And I'm going to use this identity that says if we've got sine of an angle times sine of a different angle, that's the same thing as 1/2 times cosine of the first angle minus the second angle minus cosine of the first angle plus the second angle. So let's replace what we know. Alpha is 7 theta, beta is 3 theta. So sine of alpha sine beta is the same thing as 1/2 times cosine of alpha minus beta, or 7 theta minus 3 theta, minus cosine alpha plus beta, 7 theta plus 3 theta. And really I can simplify this in one step. I don't know anything about theta here. All I want to do is add or subtract what's inside those parentheses. So this gives me 1/2 times cosine 7 theta minus 3 theta is 4 theta minus cosine 7 theta plus 3 theta is 10 theta. And that's my final answer. The only thing you might see a little bit different on these section 7 problems is if you have a negative inside the parentheses, make sure you're applying your even and odd rules to decide if that negative comes out front or if it just goes away. If you have questions on any of the Chapter 7 review, shoot me a quick email and we can set up a one-on-one or work through it in the email. Good luck on the test and let me know if you have any questions.